Hello, everybody, and welcome to lesson 11.1, adding and subtracting polynomials in your textbook on page 639. So I'm going to urge you to listen to the volume, to the audio, along with writing down all the notes. So adding and subtracting, you can only add and subtract like terms. So I'll talk more about what these are. So right above it, combine, adding or subtracting is combining only like terms. And you'll see what they are. Okay, polynomials are algebra expressions that are separated. Let's finish this down here. By a plus or minus. So that's not a multiplication or division question. All right. And to classify, add and subtract polynomials is what we're going to learn. Right here, I'm going to explain what in this space we can use. Oh, no, my thing isn't working. Hang on. Okay, solve the problem, I think. Okay, so like terms. Must have same variable, which is usually x or y. Variable raised to the same power. And remember, we can only add or subtract like terms. If they're not like, then you can't do it. So for example, let's say negative 3x to the 5th plus 4x to the 5th. So you have a negative 3 and a positive 4, and you have like terms because x to the 5th is the same variable raised to the same power. And all you do is add the numbers in front. These numbers are called coefficients. So it's really negative 3 plus 4 is positive 1. So that makes it a 1x to the 5th. You don't mess around with the variables. You just rewrite them. Or simply x to the 5th is better. Okay, so this is like terms. Now, if I like terms, anything else will not work. If I have something not like terms, just giving you an example. So for example, you have 5y squared minus 3x squared. You have the same power, but your y and your x doesn't match, so you cannot add. This is the answer. Okay, because the variables are not the same. One is y and one is x. Okay, so that's what we're doing today. We're going to combine like terms. And here they're talking about, by the way, the degree is the highest power. I don't want to go into it that much. These are all called monomial, because if you go to this page and go right up here, this is page 641. I'm just going to go there first. Here it tells you about the names. So you need to look at this chart here. You can name a polynomial based on its degree, which is your highest power. So I'll write that up here. Oh gosh, not working again. Okay, so study, all right, study. Study means you kind of familiarize yourself with it and you know where to look if you have a question about it. So if you have one part, degree is 0, it's called a constant because this never changes. It's always going to be number 6. You have one term and it's called a monomial. Mono means one. Okay, mono. If you have two terms, remember they're separated by a plus or a minus. So you have two terms, that's called degree 1. It's a linear two terms binomial. Bi means 2. Bicycle, right? 3 terms, they're separated by a plus or minus. It's quadratic and it has 3 terms. It's called a trinomial. Tri being 3, tricycle, right? And this is a monomial, but it's cubic because it has the power of 3 and it has one term. And this is a 4th degree because it has the power of 4, the highest term. It's got 3 terms. And if it has more than 3 terms, it's called a polynomial. See, the highest number of terms here is 3. It's called a polynomial. The word poly means many, and nomial, you can think of it as parts, many parts. Yeah, many parts. Polynomial. Okay, so this right here explains to you the degree, what the polynomial is called, if it's constant, linear, quadratic, cubic, or 4th degree. Remember, it's the highest power, the highest exponent that tells you that, okay? And then let's go back to the other page because I kind of skipped a little bit. This is now page 640. And I want to do problem 2, adding and subtracting. And it tells you right up here, you can add or subtract by adding or subtracting like terms. So this is important, okay? So what is the sum? Sum means adding. Okay, sum. -6, so what is the difference? Means subtracting, okay? So the sum, -6x to the 4th plus 11x to the 4th. And I noticed they're like terms. The variables are like terms, so I can add the numbers. -6 plus 11 is what, 5? So my answer is 5, and then you simply write the power. Okay, so you don't mess around with the powers. You just, these are called coefficients, by the way. The number in front of the variable is called a coefficient. All right, the difference is over here, 2x squared y to the 4th minus 7x squared y to the 4th. We have the same variables raised to the same power. So all we do is take 2 minus 7 is -5. So this would mean it's -5x squared y to the 4th. Okay, let's see, do I have, yep, this one here. Let's just do one more, couple more. You're adding like terms. If there is no number, put a 1 in front. So 8 plus 1 is 9. 9w squared x. Okay, minus 5 minus 30. First you check if they're like terms. Yes, they're all the same, right? 5 minus 13 is -8, I believe. So it's -8b c to the 4th. -8. Okay, so that's adding and subtracting like terms. A polynomial is a monomial or a sum of monomials. So this is like one part and this is another part. So that would be the sum of 2 monomials. The following polynomial is the sum. I'm just going to skip that. The degree is the highest power, okay? Standard form of a polynomial means it decreases. So this is standard form because, or descending. I call it descending order. It's because it goes from highest to lowest. So the highest power, x to the power of 4 is first, then comes x squared, that's the next, then comes the x. Last is always a number. If there is a number, that's the constant. That is always last. This is standard form or descending order, and this is the degree is 4 because that's the highest power. That's kind of all that is on this page. 641. Let's see, problem 3a, classifying, right? In standard form, what is the name based on its degree and number of terms? So remember, standard form is descending order. So you start with the highest power, which is your 8x squared plus 2x minus 3. You watch your signs. The signs in front are the ones you take with you. So this is degree 2, the highest power. It's called a trinomial because we have 3 parts, 1, 2, 3. Okay, then let's go on the bottom of this page. Remember, you can always pause the video. I'm going fast to catch up. Same question, we're writing it in standard form. We're going to name each polynomial based on the degree and the number of terms. I'm doing number 6. So the highest power is 3, but it's a negative. So I'm done with that. Then comes the plus 8c cubed, then plus. Remember, your polynomial, your terms are separated by a plus or minus, always, okay? It's in the front of the number, not behind it. Okay, so this is our answer. And then we have a degree of 7. And it's a trinomial because it has 3 parts. Okay, it's all pretty simple stuff, I feel. Let's go to page 6. Oh, what happened to my thing? Okay. 642. 642, adding polynomials. Okay, so we're going to do the word problem up here. A nutritionist studied the US consumption of carrots, celery, and broccoli over a 6-year period. A nutritionist studies what people should eat to be healthy and how many calories something has. So they find work in the hospital or in a nursing home or private, and you can make good money being a certified. You have to go to college for many years, but you make good money when you're done. The nutritionist modeled the results in millions of pounds. This is important, with the following polynomials. So you can collect data and put it into a polynomial. Okay, carrots and celery, this long polynomial, 1, 2, 3, 4 parts, so we call it a polynomial. And the broccoli, this much, this polynomial. Okay, In each polynomial, x is 0 corresponds to the first year in the six-year period. So if you plug in for x0, this goes away, this goes away, this goes away. All you're left is with a constant. That tells you we had 4,477 millions of pounds of carrots and celery eaten when they started the test. So that's what that means, okay? What polynomial models the total number of pounds in millions of carrots, celery, and broccoli? Here's the word, plus, consumed in the United States during the 6-year period. All you see is 2 polynomials. One is carrots and celery, one is broccoli. You got to add them too. Yeah, and that'll give you a polynomial for the total. So what do we think? How do you know what operation to use? Total or word and? Word and. Right here means plus. Or you add it, okay? So you're going to write carrots plus celery plus broccoli. All good stuff. Oops. Okay, so now we're going to try this the column way. I'm going to write it as a column. Okay, I'm going to write this first. Negative 12x cubed. Notice it's in descending order. 106x squared minus 241x, and last is the constant. Okay, and I'm going to add the second one, but I'm going to line up it starts with x squared, so I'm going to line it up here. So plus 14x squared minus 14x. I'm lining it up with your variables, with your like terms, plus 1545. So now you can add those. There's no, so we have, oh, I'm running into this question. I'm just going to write over it. Negative 12x cubed. We have nothing to combine here. Plus 106 plus 14, 120 x squared minus 241 plus negative 14, negative 255. Don't forget your x, plus these two together, 6,022. So there's our answer. I'll write it up here again. Negative 12x cubed plus 120 x squared minus 255x plus 6,022. Okay, so we combined our like terms. Notice I lined them up so it's easier. Okay, now this is your answer. So I don't want to, well, I'll box it. This is the polynomial that models both of these together, right? And what does the last number mean? When x was 0, all these fall away because you're multiplying a number by 0. So they all go away and you're left with 6,000 million. So I have to add, just showing you what that number means. Remember, millions of pounds of all 3 veggies at beginning of let's call it a trial. Sometimes they call it a trial when they check out, when they collect data. So that's really 6 billion, over 6 billion pounds of all 3 in the United States in a year. No, Yes, in a year. No, that's not clear if it's per year or per 6 years, because it says over a 6-year period. Sometimes it's not quite clear. But anyways, our answer is the part that I boxed here, okay? I just wanted you to look at that last number and know what it means. And then we're going to the next page. Recall the subtraction means to add the opposite. So when you subtract, there's a little trick. You have to really add the opposite. So I'll show you how that looks. Okay, I call it change all signs. So when it's negative, you make it positive and you just add, okay? Change each of the terms to its opposite. That's kind of what I do. Then add the coefficient. So when you change the signs, you just add. Let's look at this. See how you have a minus here? This means subtract. Subtract this. Okay, so I'm going, and it says, what is a simpler form? So I'm going to write the first part without the parentheses. And then I will change all the signs here. That's going to be a negative, and that's going to be a positive, and that's a negative. The plus turned into a minus, and the minus turned into a plus. Okay, really what you did, you multiplied everything by -1. And when you multiply by -1, it changes all the signs. That's kind of what happened here. Okay, just to show you why that works. Now let's look at like terms. Start with the highest power, okay? Combine like terms. So start with the highest power. Do we have a buddy for m cubed? Nobody. So just rewrite it. M cubed, nobody else to combine it with. And I like to cross out when I'm done with one. M squared is the next. We're writing in descending order or standard form. There's nobody for m squared, so I recopy it. Make sure your sign stays in front of the number. Then let's look at the m's. I have 2. And then +9 + 12 is +21. And there's our answer. So this polynomial has 4 parts, and it's degree 3, the highest power. Yeah? And it's in descending order or standard form. That's what we want. Okay. This right here is the horizontal method. This is the vertical method. You can do either one, however, which one you prefer. So we're taking the top and we're subtracting the bottom. See that minus? So that means you can change all the signs and just add it. Yeah. You're subtracting means change all the signs and add. That's what it said up here. Change all signs and add. So you're going downward. 2c squared minus c squared. I'm just going to write it over here because there's a 1 here. Yeah. It's 2 minus 1 is 1c squared or c squared. So that's c squared plus 7c plus 10c is 17c. And then we have -1 minus 4 is -5. And there's our answer. Make sure you have a plus or minus between each term. Okay. And then one more on the bottom here. We can't practice enough. Oops, my machine went haywire. There we go. Can't practice these enough. So you're going to get a lot of practice on the homework. So you need to really try. Okay, don't come to class saying you couldn't understand it. You need to try and not wait for me to show you everything. The first part, don't worry about. The second part, you need to change all the signs because we're subtracting, right? And I like to rewrite it. We'll do the horizontal way one more time. So that's a plus. That's a minus. And that's a plus. So start with the highest power. Is there any? Nope. That's a lonesome dove here, has nobody to play with, no partner. So just recopy it. Make sure you carry that negative. Look at the next one. It's the w cubed. Nobody. So it's plus 2w cubed. W squared. Put a 1 in front. Minus 4w squared right here is equal 1 minus 4 is negative 3w squared. So minus 3w squared plus the w alone. There's no constant. There's no number at the end. That's okay. Okay, 1, 2, 3, 4 parts. 4 is the highest power, so that's the degree, and it's in descending order. Okay, from highest to lowest power. All right, well, that's pretty much it for the lesson. So now let's go to the homework. Like I said, you got to practice these. Please don't ignore the homework and wait to do it in class. You can do it. Look at the example. This is more review. You've seen all this before. So I'm starting with problem 13. You're adding, simple, add combined like terms. Here you're subtracting. Subtracting is a little more difficult. You need to change the sign, right? So you have to look at the sign here between the parentheses. And then you're doing number 15, name the polynomial. This is a trinomial, second degree. Then you're going to the next page on top. This is the only word problem I believe I threw in there, and I'll give you some clues. The perimeter means you add all the sides. So I'll just write add all 3 sides. But notice you don't have a number, you have an expression. So you have to add these expressions. Yeah, remember the lesson is on adding polynomials. So you're going to add this plus this. But you don't know what this is. Your job is to figure out what this length is. The perimeter of a triangular park, so there's our triangular park, is 6. Oh, but we know the perimeter is 16x plus 3. So when you add all the sides, your answer should be 16x plus 3. What is the sum of the 2 given side lengths? This one and this one. Yeah. What operation should you use to find the remaining side length? So you know the total and you know these 2. What's the third side? That's the question. When all of them add up to this. Not that hard, but you might struggle with it a little bit. Here's an error analysis. There's a mistake. You find the mistake. Sometimes it's best to work out the question yourself and then look where the discrepancy is. So this one, simple practice problem, you add. This one you subtract. You look for these signs right here. This one you subtract, and this one you add. So these 3 are good practice problems. You might want to do them on a separate paper and stick it in there in your book because there's really no room to work it out. On the bottom, we have more. These are just practice. You're adding like terms, and then you're subtracting like terms. When you subtract, you change the sign. This is going to be a negative. Okay, and I believe that's it. And that's good luck to you. I'll see you later.